So a physical change is one in which the state or the appearance of the substance changes, but its composition does not. So if we look at this pot of boiling water, in here, in the liquid, we have these little water molecules. Doesn't that look a little bit like a Mickey Mouse head?
Yes.
Yeah, so these are little Mickey Mouse head water molecules. So we have Mickey Mouse water molecules in here. When this goes and becomes a gas, the individual molecules are exactly the same. All that has changed is that they're moving faster and they're farther apart from each other. But the actual particles are the same. That is a physical change. It's not changing the identity of the substance. Anytime you have a state change, solid to liquid, liquid to gas, etc., it's just a physical change because the particles are the same. Another way you could have a physical change. So here I've got a meter stick. If I took this meter stick and cut it in half, would that change it? Yeah, it wouldn't be a meter stick anymore. Depending on where I cut it, it might be a half meter stick, right? Is it still made out of wood?
Yes.
Yeah. So that would be a physical change, cutting something in half. The particles remain the same. In a chemical change, the particles do not remain the same. So here we have an example of an iron nail rusting. So here's the iron. It contains iron atoms arranged in a very particular way. When iron rusts, it combines with oxygen, and now the individual particles are different. We don't just have iron atoms. We have iron atoms with oxygen atoms interspersed. It's a chemical change. It's not iron anymore, now it's rust. The rust has a very different set of properties. You can't make a boat out of rust, right? Because it just won't hold together. So that's a chemical change.
Going from solid to liquid to gases.
Physical changes. Right. Because in this process, you can take iron and melt it into liquid iron. It takes a lot of heat, high temperature to do that. When you do that, you still have iron atoms. But when iron reacts with oxygen, now you do not have single iron atoms anymore. They're combined with oxygen. The particles have changed. And that's the key difference between chemical and physical changes. Here's a couple of examples. So here we have an illustration of dry ice. Dry ice is solid carbon dioxide. The reason it's called dry ice is because it doesn't melt and form a liquid, which would be wet. It goes directly into the gas state. That's called sublimation. So here we have carbon dioxide molecules in the solid state. When it sublimes and forms the gas, the individual molecules are the same. They're just separated from each other. It's like when students, you're in the solid state here, and if I let you go suddenly, you'd go out the door, you'd be in the gas state. Are you still who you are? Yeah, your personhood hasn't changed. It's just that you're farther apart from the people around you. Sugar dissolving is also a physical change. Not necessarily obvious, but you put sugar into the water, and it seems to disappear, right? But what it does is it mixes thoroughly with the water, forms a homogeneous mixture. The individual sugar molecules are the same. That's a physical change. So here's an example of a chemical change. So here's liquid propane. You release it from its canister, it becomes a gas, and then when it burns, it reacts with oxygen. So looking at the pictures here are the propane molecules. They're combining with oxygen in the air and forming carbon dioxide and water. The particles are different now. That's a chemical change. So it's all about what's happening to the particles. Summary. No, I did this yesterday too. This is not a summary of changes. This is talking about properties. So we have physical and chemical changes, and we have physical and chemical properties. That's not confusing at all. What is a physical property? A physical property is one that can be observed or displayed without changing the composition of the substance. So, the length of this meter stick, it's 1 meter, right? I can demonstrate that without changing the substance of the meter stick. A chemical property, when you demonstrate that, the original substance is destroyed. So this meter stick is made out of wood. Wood is flammable. If I demonstrate the flammability of this wooden meter stick, will I have a meter stick anymore? No, it'll be burned up. It won't be a meter stick anymore. That would be a chemical property, that it's flammable. So things like odor, taste, appearance, melting point, boiling point, density, mass, those are all physical properties. You can measure them, observe them, doesn't destroy the thing. Chemical properties are things like flammability, corrosiveness, acidity, toxicity. When you demonstrate those, a chemical reaction occurs, a chemical change occurs, and the substance has been altered. So let's look at this example. Determine whether each change is physical or chemical and what kind of a property is demonstrated. So a copper wire is hammered flat. It's going to be a physical change, right? Because are the copper atoms being combined with something else? No, we're just changing its shape. So I'm going to write, that's a physical change, so I'll call that PC for physical change. What kind of a property is that? This would be a physical property, so we'll call that PP. Sorry. Too much time spent with small children. So this property is called malleability, and it's a property that many metals have. If you hit metal with a hammer, it doesn't shatter into little pieces, it dents, right? And if you keep hammering at it, you can make it into a sheet. So here, a nickel dissolves in acid to form a blue-green solution. That's going to be a chemical change. Because do we have the nickel still? No. The nickel has dissolved, it has reacted with the acid, and now we've got this blue-green solution. Is that a chemical property or physical property? Chemical property. It always ends up that the chemical property comes from the chemical change and the physical property from the physical change. Okay, dry ice subliming without melting. Physical. Physical change, and that's a physical property. Anytime you see something indicating a state change, that's going to be a physical change. It's a physical property. How about a match igniting when it's struck on a flint? Chemical change. Chemical change is a chemical property that it will light on fire. Because after you strike that match, can you do that again? You can't do it again with the same match because you changed it. Any questions?
Is it possible to have like a chemical change and then a physical property, like the opposite?
I don't think it's possible, and that's I kind of think this question is a little bit lame. I don't think you could have something that's a physical change demonstrating a chemical property, or vice versa. They're going to go hand in hand. Good question.